have already discussed the first principle of differentiation, and we've given 4 steps to finding the first principle. We'll be able to identify difference equation and derivative. Now we are going to go through certain illustrations. We'll be solving the following questions to demonstrate what you've learned so far as the differentiation through the first principle. So the first question, we've asked to find the derivative through the first principle of the function y equals to s squared plus 5s plus 6. Remember the steps I gave you. The first thing you do is what? You express y plus change in y as a function of s plus change in x. Now this is y is equals to f of s, and f of s is, this is y equals to f of x equals to s squared plus 5x plus 6. Put it to question 1. So the first step we are going to do here is now express y plus change in y as a function of f of s plus change in s. That is, y plus change in y equals to f of s plus change in s equals to, what this means is that everywhere you see x here, you replace it by what? S plus change in x. What this means is everywhere you see x in equation 1, you replace s by s plus change in x. That is, you have s plus change in s squared plus 5 into s plus change in x plus 6. I like to call this equation 2. So now, this is what we'll be dealing with. This is what we'll be dealing with. So our y plus change in y now equals to what? S plus change in x, s plus change in s. Since s plus change in s squared can be written as this, plus 5 into s plus change in x plus 6. We have to open this bracket. We have y plus change in y equals to s into s plus change in s plus change in s into s plus change in x plus 5 into s plus change in x plus 6. Do you get it up to this point? We've not done anything besides just basic arithmetic or algebra. Here we substitute s plus change in s for anywhere we find x here, and the next thing we do here is that we open this bracket. We write this as s plus change in s times s plus change in s. Then when we get here, we what? To open this bracket, we use s to multiply through here, and we use change in s to multiply through here. That's what we have here. So going further, our y plus change in y equals to what? S times x, which is s squared, plus s times change in x, which is s change in s, plus change in s times x is same thing as s change in s. Change in s times change in s, we have what? Plus change in s squared. Always write change in s, put it in bracket before you put your square. If you are giving something like this, don't just write change in s square, because this might mean change in s square, not everything square, as 2s square is not equals to what? 2s square. Okay, so always put the bracket there. Plus 5 times x, that will be plus 5x plus 5 change in x plus 6. Now, can we collect the like times here? Here we can collect the like time. We have s plus change in s plus s plus change in s. This can be added together. So we have what? Y plus change in y equals to s squared plus 2x change in x plus change in s all squared plus 5x plus 5 change in x plus 6. Now the next thing we do here is what? We want to find our change in y, as we've already stated in the first steps. Find our change in y here. What we do is what? We subtract through by y. So subtract through by y. You can write subtract y from both sides, it still mean the same thing. So here we have y plus change in y minus y equals to x squared plus 2x change in x plus change in s all squared plus 5x plus 5 change in x plus 6 minus y. Coming. Let me give this equation 3 and let me give this equation 4. All right, here we have to recall that our y is already given. Y is given already in the equation as y equals to s squared plus 5s, recall, plus 5x plus 6. Therefore, substitute for y in equation 4. So what this is telling us is that where we find y in equation 4, we substitute s squared plus 5s plus 6 for y. And by so doing, y plus change in y minus y, this turns to what? Change in y equals to s squared plus 2x change in x plus change in s all squared plus 5x plus 5 change in x plus 6 minus y. But now we are not writing our y, we are writing this as a substitution for y. Minus, we put it in brackets, s squared plus 5x plus 6. Now we open this bracket, then we have change in y equals to s squared plus 2x change in x plus change in s squared plus 5x plus 5 change in x plus 6 minus s squared minus 5x minus 6. From here, what do we do? From here, what we do is s squared minus s squared cancels each other, plus 5s minus 5s cancel each other, plus 6 minus 6 cancel each other. So therefore, change in y equals to 2x change in x plus change in s all square plus 5 change in x. This will give us what? Equation 5. This is out, this is out, and this is out. So now remember, I said you find your difference equation. Now difference equation is changing y right by changing s, so which means what we simply do here is what? We divide through by changing s. Divide through by changing x. Therefore, changing y over changing s equals 2s changing s over changing s plus changing s changing y over changing s equals 2s changing s over changing s plus changing s all square over changing s plus 5 changing x over changing x. When you apply this division, we have changing y equals changing s, which give us what? 2s plus changing x plus 5. Now this is our what? Our difference quotient. These are our different quotients. These are our different quotients, and we have to find the what? The derivative through the first principle. That is, we have to find the dy dx. By definition, the derivative is the limit of the difference quotients when changing s tends to 0. That is, the y, the s here, equals to limit changing y over changing s when what? Changing s tends to what? 0, equals to limit 2x plus changing x plus 5 as what? Changing s tends to 0. So by implication, wherever you see change in x, you replace it by 0 here. So therefore, what we have left is what? Dy dx equals to 2x plus 0 plus 5 equals to 2s plus 5. The derivative of y equals to s squared plus 5x plus 6, the dy dx equals 2s plus 5. We just find the derivative of this function using the first principle. We apply the step by steps we are taught earlier on, and so we move on to the next question. The next question, we are asked to differentiate through the first principle y equals to 1 over x minus 3. Now, by just the made 1 over s minus 3, many of you out there, you're already confused. Now, it's very, very simple. It's still exactly the same. We just little change, but nothing really changed, just the same procedure. So the first steps I said is that what? You express y plus change in y as a function of what? S plus change in s. Recall, from my previous solutions, I said y equals to f of x equals to 1 over s minus 3. This is what we are given. This is what we are given. And now we want to now find what? Y plus change in y, which is what? A function of what? S plus change in s, which means anywhere we see x here, we substitute s plus change in s for s, then we have what? 1 over s plus change in x minus 3. Now we can call this equation 1, while we call this equation 2. Now from here, we make change in y subject of the formula by subtracting both sides by y. So we have what? Change in y equals to 1 over s plus change in s minus 3 minus what? 1. We have to recall that our y is equals to 1 minus 1 over s minus 3. Our y equals to 1 over s minus 3. So we substitute the value of y in equation 3. So therefore, change in y equals to 1 over s plus change in s minus 3 minus 1 over s minus 3. So having gotten to this part, now should we leave it here and divide both sides by changing s? I say no. So what we do is what? We apply our little knowledge of what? Of fraction. So the LCM here in this division, the LCM here, lowest common multiple will be what? S plus change in s minus 3 and what? S minus 3. The product of the two will be our LCM here, which if we take this as the LCM, we have what? Change in y equals to what? S minus 3 minus into bracket s plus change in s minus 3 all over s plus change in x minus 3 s minus 3. So this is the LCM. When we use this as the LCM, we turn this to this. So what we do next is we open this bracket, we have our change in y, which is equals to x minus 3 minus x minus change in x plus 3 all over s plus change in x minus 3 x minus 3. Now from here, plus s minus s equals to 0, 3 plus 3 equals to 0. So what do we do from here? Our change in y, equals to this cancel this, minus change in x all over s plus change in x minus 3 s minus 3. Let's call this equation 4. Look. So from equation 4 now, we have to find our difference equation. Now, how do you find our difference equation? Again, you find our difference equation by divide through by change in s, as our difference equation is equals to change in y over change in s. So therefore, we divide both sides by change in x. You have to write this down in examination sake. All these procedures, you write them down. You divide, subtract, take somewhere of the formula. You have to write all of them in examination situation. So our change in y over change in x equals to what? Minus change in x over s plus change in s minus 3 x minus 3. Everything divided by change in x. This equals to minus change in x over x plus change in x minus 3 s minus 3 times 1 over change in x. From here, change in s cancels change in s, as change in s divided by change in s is equals to what? 1. So therefore, our change in y over change in s equals to minus 1 s plus change in s minus 3 s minus 3. This is our difference equation. Now we've gotten our difference equation. All that we have to do now is to find the what? The derivative. Now, how do you find derivative? We take the limit of our difference equation when change in s is equals to 0. So what we do is divide the s equals to limit of change in y, change in s when change in s tends to 0 equals to limit minus 1 s plus change in x minus 3 into s minus 3 when change in s tends to 0. So this equals to whatever you find change in s, you put 0 there. This will be minus 1 all over s minus 3 x minus 3. So therefore, dy dx equals to minus 1 into what? S minus 3 s minus 3. You can either open this bracket by turning things into what? Into s square, use s to multiply all through, even as you multiply all through, or simply write this also equivalent to what? Minus 1 into what? S minus 3 square. So that's the derivative of y equals to 1 over s minus 3 through the first principle. This is another question we are asked to solve with the first principle. Here we have f of s equals to 2s minus 5 divided by 3s plus 6. Recall, don't forget, see, in calculus, in mathematics general, statistics also, every little details is of importance. When I'm solving, I'm writing y equals to f of x equals to the equation that is given. Some of you will like, why is he writing f of s there since we are already given y equals to s squared plus 5s plus 6. This is y. This they give you isn't as y. Okay? So for the fact that someone see f of s here, some of the students will be confused, and by just this, they might lose the question. They might just leave it and go and solve another question they don't know well enough. So simple. Every little details is of importance in calculations. So let's go on. This same thing as y equals to f of s equals to 2x minus 5 over 3s plus 6. So with the same thing we do, we express this in the new position, that is, we express y plus changing y as a function of s plus changing s. That is, y plus changing y equals to f of s plus changing s, which means whenever we see s here, we substitute what? Whenever we see s, we substitute s plus changing s. So we have this equals to 2 into what? S plus changing x minus 5 into 3 into what? S plus changing s plus 6. Let's call this equation 1 and let's call this equation 2. Okay? So let's open this. We have what? Y plus changing y equals to 2s plus 2 changing s minus 5 all over 3x plus 3 changing x plus 6. So from here, let's find our change in y by subtracting both sides. That's by subtracting y from both sides. From here, we find our change in y by subtracting y from both sides. So therefore, we have what? Change in y equals to 2s plus 2 change in x minus 5 all over 3s plus 3 change in s plus 6 minus y. Recall, our y is 2s minus 5 over 3s plus 6. So we just substitute this value for y. Let's call this equation 3. Substitute this value for y in equation 3. Then we have change in y equals to 2s plus 2 change in x minus 5 all over 3s plus 3 change in x plus 6 minus 2x minus 5 all over 3s plus 6. So from here, we cannot go any further until we find the what? LCM. We need to find the lowest common multiple once again, and our lowest common multiple here is what? 3s plus change in s plus 6 times what? 3s plus 6. That will be our common multiple. That will be our common multiple. So our LCM here, we have 3s plus 3 change in x plus 6, 3x plus 6. So when you use this our LCM, then our change in y will be change in y equals to 2x plus 2 change in x minus 5 into 3x plus 6 minus 2s minus 5 into 3s plus 3 change in s plus 6 all over our LCM. 3s plus 3 change in s plus 6 3x plus 6. Let's call this equation 4. From here, let's open this bracket. Let's open this bracket and see what we get. So our change in y equals to 3s into 2s plus 2 change in s minus 5 plus 6 into 2x plus 2 change in s minus 5 minus 2x into 3s plus 3 change in s plus 6 minus 5 into 3s plus 3 change in s plus 6. I believe from our knowledge of Lesson 103, how I open that bracket is well understood by everyone. 3 change in s plus 6. If you don't, then revise your Lesson 103. Mathematics is always a continuous journey. The very mastery of the foundation is important to know what comes next. So let's go forward. Change in y equals to 3s times 2s. We have what? 6s squared. 3s times 2 change in s. We have plus 6x change in x minus 15x plus 12x plus 12 change in x, right? Minus 30 minus everything in bracket. This 6s squared plus 6s change in x plus 12x minus 15x minus 15 change in x minus 30. Everything over 3s plus 3 change in s plus 6. 3s plus 6. Let's collect like times here. Let's collect like times here and let's open this bracket with the minus. We have 6s squared. 6s squared, this 6s change in s, this 15x plus 12x, this can work together, this 12x. So we have 6s squared plus 6s change in x. Now 15x plus 12x, that gives minus 3x. That's minus 3x plus 12 change in x minus 30. If you walk here too, we have 6s squared plus 6s change in x. This 12s minus 15s, which gives minus 3x minus 15 change in x minus 30. All over 3x plus 3 change in x plus 6 into bracket 3s plus 6. Going further from here, let's open this bracket. We have 6s squared plus 6s change in x, s change in s minus 3x plus 12 change in x minus 30 minus 6s squared. When you open this bracket with the minus 6s change in x plus 3x plus 15 change in x plus 30, all divided by our LCM 3x plus 3 change in x plus 6, 3s plus 6. So from here, obviously 6s squared minus 6s squared, this cancel this. 6s plus change in s minus 6s plus change in s, this cancel this. Minus 3s plus 3s, this cancel this. Plus 12s change in s plus 15s, they are together. Y minus 30 and plus 30 cancels each other. So going further, our change in y equals to 12s change in s plus 15s change in s give us 12 change in s plus 15 change give us 27 change in x divided by 3x plus 3 change in x plus 6 all into 3x plus 6. Let's name this equation 5. Going further from here, if you got into this place, you are almost done. But you have to be very careful in solving this question. Be sure you don't make any mistakes in your bracket expansion. When you are removing the bracket, be mindful of the signs and be certain that there is no error. You can check and recheck again. So from here, we have to find difference equation. Our difference equation is change in y over change in x. So which means all we are doing here is what? We are dividing through by change in x. So we are dividing through by change in x. That is change in y over change in x equals to 27 change in x over 3s plus 3 change in s plus 6, 3s plus 6 multiplied by 1 over change in s. So you are dividing through by change in s, same thing as multiplying by 1 over change in s. So from here, this change in s is going to cancel this. This is going to cancel this. Then this, our change in y over change in s, change in y, change in s will be 27 over 3x plus 3 change in s plus 6 all over 3s plus 6. This is our difference quotient. Don't ever forget that. It's important. So now all we have to find now is find the derivative. Like find the dy ds. Remember, the derivative or the dy ds is the limit of our difference quotient when change in s tends to 0. So therefore, the y, the x equals to limit of change in y over change in s when change in s tends to 0 equals to limit of 27 3s plus 3 change in s plus 6 3s plus 6 when change in s tends to 0. So whenever there is change in s, you replace it by 0. So your dy ds equals to 27 over 3x plus 6 3x plus 6. So therefore it's equals to 27 over 3s plus 6 squared. That this is the derivative of the function. And by this, we've come to conclude the first question in our illustration. So this is the next question in our illustration. We have y equals to 6s squared plus 4s plus 5. If you look at this question very well, it is very similar to the first question we do. Number one question, so I don't know, I don't really have to solve this, but for the sake of those who didn't really get to understand how I solved that question, so I'll just solve it. Okay? So if you're solving this, recall the way I solved the previous one. We said y equals to f of s equals to 6s squared plus 4x plus 5. So from here, we express y plus change in y as a function of s plus change in s. So we have y plus change in y equals to f of s plus change in s. Equation 1. So here, anywhere we see s, we substitute s plus change in s there. So we have 6 into s plus change in s square plus 4 into s plus change in s plus 5. Equation 2. So here y plus change in y equals to 6 into, when you expand this by finding s plus change in s into s plus change in s. When you expand this, what you get is what? It be s square plus 2s change in x plus change in s square. So plus 4x plus change in x plus 5. So when you expand this further, you get 6s square plus 12x change in x plus 6 change in s all square plus 4x plus 4 change in x plus 5. Check if there is like times. Is there any like times there? No, there's no like times there. So we go on with our solving. We make change in y set of the formula, then change in y equals to 6s square plus 12s change in s plus 6 into change in s all square plus 4s plus 4 change in s plus 5 minus y. Recall our y is same thing as 6s squared plus 4s plus 5. So therefore we substitute this for y. So we have minus 6s squared plus 4s plus 5. So our change in y equals to 6s squared plus 12s change in x plus 6 into change in s squared plus 4s plus 4 change in s plus 5 minus 6s squared minus 6s squared minus 4s minus 5. So this 6s squared cancel 6s squared minus 4s cancel plus 4s and plus 5 minus 5 cancel each other. So that is, this goes with this takes this out, and this take this out. So we are left with change in y equals to 12x change in x plus 6 change in s square plus 4 change in s. So what we're doing now is what we divide through by change in y, change in s. So therefore change in y over change in s equals to 12x change in s over change in x plus 6 change in s all square over change in s plus 4 change in x over change in x. So change in y over change in s equals to 12x plus 6 change in x plus 4. We call this equation, and this equation 3, and this is our difference quotient. This is our difference quotient. Now we are to find the derivative. We all know that the derivative, which is the dy ds, is the limit of our difference quotient when change in s tends to 0. So from here, we find our dy dx, which is the limit of change in y over change in x when change in s tends to 0, which is the limit of 12x plus 6 change in s plus 4 when change in s tends to 0. All you do is wherever you see change in s, you put 0 there. So this dy ds equals 12x plus 6 into 0 plus 4 equals 12x plus 0 plus 4 equals 12s plus 4. So that is the derivative of y equals to 6x squared plus 4x plus 5. This is the derivative of y equals to 6x squared plus 4x plus 5.
Oh.
So this is the last question we'll be looking at with solving calculus differentiation using the first principle. So this question, it's in three parts. The A part of it asks us to find the difference quotient. You know, I've always been telling you, the question I'm solving, what the different quotient is. So it's still the same procedure. So y equals to f of x equals 3x squared plus 8. Y plus changing y equals to f of s plus what? Changing s equals to 3 into s plus changing s square plus 8. So here we have what? Y plus changing y, 3 into s square plus 2s changing s plus changing s square plus 8. Then y plus changing y equals to 3s square plus 6s changing x plus 3 changing s all square plus 8. Then we subtract y from both sides, then changing y equals to 3s square plus 6s changing s plus 3 into changing s square plus 8. Our y is 3s square plus 8, so minus 3s square plus 8. So changing y equals to 3s square plus 6s changing s plus 3 into changing s all square plus 8 minus 3s square minus 8. This cancels this. Why? This also take this out. So changing y equals to 6s changing s plus 3 changing s all square. Now to find our difference quotient, we divide through by changing x. So changing y over changing s equals our difference quotient equals 6s changing s over changing s plus 3 changing s all square over changing x. So changing y over changing s equals to 6x plus 3 changing s. This is our difference quotient. The B part of this question asks us to find the derivative of the function 3x squared plus 8. Now we already find our difference quotient, so the derivative will be dy dx limit of what? Changing y changing s when changing s tends to 0 equals to the limit of 6s plus 3 changing x when changing x tends to 0, which equals to 3s plus 3 into 0 that equals to what? 6x. So therefore the dy dx here is equals to what? 6x. Also, forget this. Let me remind you. This can also be written as what? D 3s squared plus 8 dx equals to 6x. This also is written as what? The derivative of the function 3s squared plus 8. The C part of the question, we have to find the average rate of change in y when x equals to 4 and change in s equals to 3. So to find the average rate of change in y, all we simply goes well, we use our what? Our difference quotient. Use our difference quotient. Recall, our difference quotient is still this. So all we have to do is what? We substitute 4 for x in our difference quotient, and we substitute 3 for change in s in our difference quotient. So therefore we have 6x plus 3 into change in s to be equals to 6 into 4 plus 3 into 3. 6 times 4, this will be 24 plus 9, which is equals to 33. So therefore, the average rate of change in y is 23. I hope this is very understood. As far as first principle is concerned, I don't see any question coming out in any examination beyond these that I've discussed. And for the sake of intellectualism's sake, I've been able to simplify differentiation through the first principle. If you ever encounter any questions that you can't undo based on the explanation given and the question illustrated solved, feel free to message me directly, as I will be more than happy to handle them and explain them for you and also share it to the rest of the world. Thank you. Don't just watch, like and subscribe. Thank you.